This is the video discussion for the introduction to Linux. Again, Linux essentials are adopted in cybersecurity as for the fact that there are security tools that we are to explore, and most of the security tools are under the Linux operating system. So, in this video, we'll look into the evolution of Linux and popular operating system, discussions on choosing an operating system, and also major open source application, understanding open source software and licensing, ICT skills, working in Linux and command line basics. Again, this is mapped in the Linux Essentials under the Cisco NetAcad training module. So again, we are adopting Linux administration, well, because as I noticed there, this wasn't explored to you in your other course. And another is that very important to have an in-depth understanding of at least the environment command lines that the Linux has. Well, because if we were to proceed in Cyber 2, 3, and 4, there are security tools under Linux that you are to explore. This is one application that the Linux has. Okay. So most software has been issued under a closed source license, meaning that you get the right to use the machine code, but you cannot see the source code. Often the license explicitly say that you might not attempt to reverse engineer the machine code back to source code to figure out what it does. The development of Linux closely parallels the rise of open source software. The open source has a philosophy that you have a right to obtain the software source code and to modify it modify it for your own use. Linux adopted the philosophy to great success. Linus made the source programming code freely available, allowing others to join in and shape this fledgling operating system. It was not the first system to be developed by a volunteer group, but since it was built from scratch, early adopters could influence the project's direction. People took the source, made changes, and shared them back with the rest of the group, greatly accelerating the pace of development and ensuring mistakes from other operating systems were not repeated. Initially, the original Linux with GNU Tools, they added user-facing applications like browser and email client. And when programmers, organizations, and companies found Linux usable, they started bundling their developed software into Linku, resulting into what we call as distributions. The distributions includes tools that take care of setting up the storage, installing the kernel, and installing the rest of the software. The full-featured distributions also include tools to manage the system and a package manager to help you add and remove software after the installation is complete. There are distributions that focus on running servers or desktops or even industry-specific tools such as electronic design or statistical computing. Major players in the market that can be traced back to either as Red Hat, Debian, or Slackware. This is for the Linux. Typically, operating systems offer both GUI and CLI interfaces. However, most consumer operating systems like Windows or Mac operating system are designed to shield the user from the complexity of the CLI. The Linux community is different in that it positively celebrates the CLI or command line interface for its power, speed, and ability to accomplish a vast array of tasks within a single command line instruction. The virtual machine used for the chapters and labs in this course provide a CLI for you to practice on without fear of damaging anything. So when a user first encounters the CLI, they can find it challenging because it requires memory or dizzying amounts of commands and their options. However, once a user has learned the structure of commands, of how commands are used, where the necessary files and directories are located, and how to navigate the hierarchy of a file system, they can be immensely productive. This capability provides more precise control, greater speed, and the ability to easily automate tasks through scripting. Furthermore, by learning the CLI, a user can easily be productive almost instant on any distribution of Linux, reducing the amount of time needed to familiarize themselves with the system because of variations in a GUI or graphical user interface. An operating system, by definition, is a software that runs on computing device and manage the hardware and software components that make up a functional computing system. So, the operating system, based on this diagram, is the one that connects the hardware going to the interface where the user interacts with. And again, as what we have mentioned, is that the operating system has two environments. We have the CLI, command line interface. So Linux, on top of its GUI base, there's of course always the CLI. So that's like in this course, that's our agenda to familiarize ourselves with the different commands, um, very important commands that we need in order for us to administer this Linux operating system. Again, operating system also, one of its main function is to manage the application software that it has, schedule programs to run, and provide services to the users. Modern operating systems don't just manage hardware and software resources. They schedule programs to run in a multitasking manner, like sharing the processor so that multiple tasks can occur apparently simultaneously, provide standard services that allow users and programs to request something happen from the operating system, and provided it's properly requested, the operating system will accept the request and perform the function needed. Desktop and server operating systems are by nature more complex than an operating system that runs on a single-purpose device like a firewall or a mobile phone. From a simple set-top box that provides a menu interface for a cable provider to a supercomputer and massive parallel computing clusters. The generic term operating system is used to describe whatever software is booted and run on that device. I have five factors here under decision points of an operating system. First is the role. So like what will be the role of the operating system? Will it be standalone, or will it be a network operating system, or will it act as a server? Will it be accessed remotely, or will there be any permissions or restrictions? These are the items that are all under the role. Or let's say servers, usually they typically sit in a rack and share a keyboard and monitor with many other computers, since console access is generally used for configuration and troubleshooting. So like servers, they generally run in a CLI or command line interface, and this frees up resources for the real purpose of the computer, serving information to clients, not like usually desktop systems. They usually run in a GUI or graphical user interface for the ease of use of their users. As for the function, items to consider is like in the function, will there be specific or proprietary software it needs to run, or specific function it needs to perform? Like example, in Apple computers, its operating system is specific, and that is Mac, and that is the Mac operating system, not like in Linux. So there are different distributions or variations. So will there be hundreds or even thousands of machines running at the same time? Well, this is because of the virtualization, right? We'll explore more of the virtualization in Cyber 2. And the next in the item is life cycle. It is important to know the service lifetime and risk tolerance of the operating system. Like operating systems and software upgrades come on a periodic basis, and we call this as a release cycle. Vendors only support older versions of software for a certain period of time before not offering any updates. It is called a maintenance cycle or life cycle. In an enterprise server environment, maintenance and release cycles are critical considerations because it is time-consuming and expensive to do major upgrades. Nowadays, there's too much work in upgrading a server due to specialized configurations, and then application software patching and user testing. So a proactive organization will seek to maximize their return on investment in both human and monetary capital, and this challenge is now addressed through virtualization. In a virtual environment, one physical machine can host dozens or even hundreds of virtual machines, decreasing space and power requirements. Example of companies who offer cloud services or like in the virtualization field are Amazon Web Service or Rackspace or even Microsoft Azure. Next in the decision point is the stability. In here, Individual software releases can be characterized as, say, a beta or a stable depending on where they are in the release cycle. When a software release has many features that haven't been tested, it's typically referred to as beta. After being tested in the field, its designation changes to stable. So users who need the latest feature can decide to use beta software, and usually if beta, it is still in the development phase of a new development. Software in the open source realm is often released for peer review very early on its development process, and can very quickly be put into testing. And conversely, proprietary software will often be kept secret for most of its development, only reaching a public beta stage when it's almost ready for release. And last in the item is the compatibility. So another loosely related concept is the backward compatibility, which refers to the ability of later operating system to be compatible with software made for earlier versions. This is usually a concern when it is necessary to upgrade an operating system, but an application software upgrade is not possible due to the cost or lack of availability. Most common practice of maintaining and versioning libraries of functions helps this greatly. Typically, a library that is used by one or more programs is versioned as a new release when significant changes have occurred, but also keep all the functions of earlier versions that may be hard-coded or referred to by existing software. And last in the item is the cost. Cost is always a factor when specifying new systems. Microsoft has annual licensing fees that apply to users, servers, and other software, as do many other software companies. Ultimately, the choice of operating system will be affected by available hardware, staff resources, and skill, cost of purchase, maintenance, and projected future requirements. Virtualization and outsourced support services offer the modern IT organizations the promise of having to pay for only what it uses rather than building in excess capacity. This is not only control costs, but offers opportunities for people both inside and outside the organization to provide expertise and value.